Hi everyone, go ahead and check your day 3 answers. And of course, pause the video if you need more time. If you have any questions on this assignment, feel free to talk to each other. And then also you can stop by after school and see any math teacher to get some help if you're stuck. All right, so today we are going to work on the day 4, which is area of regular polygons. This will not be on your quiz tomorrow. Your quiz tomorrow will just be on days 1 through 3. All right, so take a moment and go ahead and circle all the regular polygons. You should be circling anything that has congruent sides with the congruent angles. So you should have circled this red one, this yellow one, this other yellow one, the pink one. So those are the regular polygons, and those are what we're going to focus on today, finding their area. So just a quick review. See if you can fill these in before I do. The properties of regular polygons include the following. All sides are congruent. All interior angles are congruent. All exterior angles are congruent. The radius, which is going to be the center to a vertex, is going to bisect the angles. So I'll show you that in a minute. And then if you remember, the sum of the interior angles always changes. It's based on the formula 180 and then times m minus 2. And remember, m or n is the number of sides or angles. So these are some things we want to keep in mind. So new term, it's called the apothem. And the apothem simply is a perpendicular line segment drawn from the center of a regular polygon to one of the sides, and it's going to hit the midpoint. So this is the midpoint, and it's perpendicular. So that's the apothem. So this red line right here, that's the apothem. All right, so what are its properties? Well, it's going to bisect that opposite side. So as you can see, it's been bisected. And it's also going to bisect the center angle. So what does that mean? So if I take my straight edge and I connect the center to each of these vertices, this right here is a center angle. So that angle has been bisected. So this angle is congruent to that angle. So the apothem does all those things. Okay. All right, so how are we going to figure out the area of a regular polygon? So why don't you take a moment and think about it. Look back at this picture and see if you notice anything interesting about that picture. Feel free to pause the video if you want additional time to think. All right, maybe you noticed that I can divide up the polygon into isosceles triangles. So if I look back here, all these radii are congruent. So I can divide up this pentagon into 5 isosceles triangles, because remember, each of these are congruent. So I've got 1, 2, 3, 4, 5 triangles. Next, I'm going to find the area of one of them, one of the isosceles triangles. And lastly, I just have to multiply the area by the number of triangles. So let's try one. And what's neat about these problems is that there's always more than one way to do them, but there might be an easiest way. So I'm going to try to always show you the easiest, but just because it's the easiest, it might not be the way your brain works, and you can always do it a different way. So we have to find the area to the nearest hundredth of this regular octagon with a radius of 20 inches. So first of all, let's draw in where 20 inches would be. So go ahead and do the center. And the radius is going to be from the center to the vertex. That's what the radius is in these regular polygons. And now I could keep drawing them in. And go ahead if you want to. And you should notice that you have how many triangles? You should notice 8. So if I can find the area of one triangle, I can just multiply by 8. So let's see, how do I find the area of a triangle? Well, they're telling me that the radius is 20. So that's 20 and that's 20. So let's just focus on this triangle right here. So I'm given two triangles, or two radii, that are each 20, that make up this triangle right here. So I can't use this formula very easily because I don't have a what? You should be thinking I don't have a height, and I don't know what this base would be. I could sketch it in, but I would have to do a lot of work to figure out what this height is and this base. So you might remember that we learned area of a triangle is also 1/2 AB sine of C. This is way easier. You already have two sides. You have the 20 and this 20. So if we can figure out the included angle, we can use that formula and we're done. It's super easy. So how am I going to figure out that angle? Well, all the way around makes 360. So 360 divided by 8. I'm going to figure out what that is. 45 degrees. So that means my formula is 1/2 A B sine of C, which is 45 degrees. That's the area of one triangle. How many triangles do I have? I have 8. So I just have to put this in my calculator and I have my answer. So we have 8 times 1/2 times 20 times 20 times the sine of 45. Make sure you're in degrees and then hit enter. And I don't remember what it said. Nearest hundredth. Okay, so it's the nearest hundredth place. Oh, it looks like I only have hundredths, so I better check to make sure in my settings. Oh, I am on float. Interesting. All right, well, I guess that's what it is, the nearest hundredth. So I have 1,131.37. I find that odd. Just gonna check something quick because okay, I don't know, that's so weird. Okay, anyway, I knew that the sine of 45 was irrational, so I knew there should be more decimals. So that's why I wanted to double check. So as you can see, I got more decimals the second time. I don't understand why my calculator didn't show them before, but oh well, now we're good. All right, let's try it again. We have find the area of the regular hexagon with a side length of 8. So hexagon, I need to draw in at least one triangle. You probably already know that how many can I really draw in? 6. So 6 times the area of one triangle. Okay, so I got to figure out which area formula I want to use. The side length is 8. So that means this is 8. Okay, so I'm focusing on this triangle. I have the base. So I could figure out the height to use A equals BH divided by 2. Or I could figure out another side and this angle. It's really up to us what we want to do. I'm guessing because I have this base, a lot of you are thinking about finding this height. All right, so how would I go about doing that? Well, I still want to figure out this angle. So 360 divided by 6 tells me that this angle right here is 60 degrees. If this angle is 60, remember, this altitude I dropped is also known as the apothem. It's going to break up or bisect that angle. So that means that if I just focus on this right triangle, this angle here is 30, which makes this 60. And this bottom piece is 4. So I have across from the 30 is 4. Wait a minute, I got a 30, 60, 90. So across from the 30 is 4. That means across from the 60 is 4 radical 3. And 2 times 4 is 8. So this is 8. And this is 4 radical 3. Wow, I have so much information. So if I still want to use base times height divided by 2, then I would do 4 radical 3 times the whole base, which is 8, divided by 2. Whatever I get here, I still have to multiply by 8. So I could put that in my calculator and be done. Or I could use 1/2 AB sine of C. So if I want to use that one, I have this angle as 60, and I have the two sides, whoops, the two sides are both 8. And then I have to multiply by 8. Both of these will give me the exact same answer. So if I do 4 radical 3 times 8 divided by 2, I'm going to hit enter and then times 8. And then I think it said nearest hundredth again, so 0.70. So either one of those, yep, it did. Either one of those will work. You can just pick whichever one is easier for you. Could you have used SOHCAHTOA? Yes, because it doesn't say exact value up here. It says you're going to round, but I thought it was easier to bring back our 30, 60, 90 since I had the 30, 60, 90 triangle. All right, try it again. Find the area of a regular decagon with an apothem of 10 centimeters. All right, so here's my center. Draw in your triangle. At this point, we know there's going to be 10 triangles. Okay, the apothem is 10, not the radius, the apothem. So that's the altitude of this triangle. So that means I have the height of this triangle. No matter what I want to do next, I need to come up with the central angle right here. So 360 divided by 10 is 36 degrees. This entire angle is 36. But when I cut it in half, because it bisects, remember, I get 18. So if I look at this angle, or this triangle right here, this is 18 degrees. And I know that's 10. So most likely, because I already have the base, it'd be really nice if I could, excuse me, the height. If I could just get this base, I'd be done. So I'm going to put a little X right here. And how can I figure out what this piece is right here? Well, I have a right triangle. I have a right triangle. Oops, this is 10, sorry, this is X. This is 18 degrees. So that means what I can do is use SOHCAHTOA to figure out what x is. So this is my angle 18. This is my opposite. This is my adjacent. That's tangent of 18 equals opposite over adjacent. So that means my base of this triangle right here is 10 times the tangent of 18. But that's only this piece right here. I need the whole base, which means I have to double it. So I have 2 times 10 times the tangent of 18, whatever that is, and that's the base of this triangle right here. My height is the 10. So this is the base, and my height is 10, and then I have to divide by 2. So I have the height times the base divided by 2, and I'll get my answer. So fraction bar, 10 times 2 times 10 times the tangent of 18, and then I'm dividing by 2. So 32.49. And we should emphasize that this is area, so my units are squared. All right, what do we got now? We have the perimeter of a regular decagon is 220 inches. Its radius is 35.6 inches. What is the decagon's area? All right, so if the perimeter is 220, that's all the way around, right? Adding all these up. Decagon has 10 sides. So that means each side is really 22. All right, so draw in that triangle. This is 22. I've got the radius is 35.6. This is also then 35.6. They're actually giving me more information than I really need because I have these two sides. What angle do I need in order to use this equation? Hopefully you're thinking this angle right here. So 360 divided by 10 sides is 36. So this whole angle is 36 degrees. Oh my goodness, my pen is not working. There it goes. So I have 1/2. The A is 35.6 and another 35.6 times the sine of 36. And then how many triangles do I have? It's a decagon, so that means there's 10 of them. Okay. Oh, did I forget to multiply on that last one? I think I might have. I should go back and look in a second. All right, so let's type that in. So we have 10 times 1/2 times 35.6 times 35.6 times sine of 36. And we have 1,489.87 to the nearest hundredth, and that's units squared. Okay. All right, before we keep going though, I feel like I forgot to multiply by the number of triangles. Let me just double check. So this was my base. This is my height, and I divide by 2. I did not multiply by the number of triangles. So how many triangles were there? 10. Look, I even wrote it here, but I didn't write it here. So really, I should have multiplied by 10. That's going to move my decimal over 1. So my answer is not 32.49. It's going to be 320 point. Oh, I got to look back at my calculator. Let's see. So this number right here, I have to multiply by 10. I'm glad I caught that. So we have 324.92 units squared when I multiply that by 10. All right. Okay, 5. At this point, I think this is our last one. Oh, we have 2 more. At this point, I would say pause the video and try to set up one on your own. I'm going to keep going. So the area of the rectangle of the pentagon is 175. Its side length is 10. Can we figure out the length of the apothem? So the apothem is this right here. This going down like this. And I'm told that the area is this. And the side length is 10. So if this is the area, I have to divide it by 5 first to get the area of one triangle. So 175 divided by 5 is 35. That means the area of one of these triangles is 35. And they're giving me the base. Notice the apothem is actually the height. So 35 equals base times height divided by 2, right? One area. And I know that the base is 10. So I've got 35 equals 5 times the height. Divide by 5. The height or the apothem is 7. Excuse me. All right, so that one wasn't too bad. That was going backwards a little bit. All right, last one. We have if the regular octagon with a side length of 8 radical 3, find the area to the nearest hundredth. So our side length is 8 radical 3. Draw in your triangle. It's an octagon, so 8 times the area of one triangle. So that's at 8 radical 3. I always want to start with at least finding that angle. So 360 divided by 8 is what? It's at 45. Okay. So if I drop the apothem, which is also the altitude here, I can figure out the other ones. Now, real quick, before I do that though, just a side note here. If this is 45 degrees, remember, these radii are the same. So what does that make these angles? You should be thinking congruent. So if I take 180 and subtract 45, how much is left for those two base angles? Oops, I divided twice. See that? 135 divided by 2. 67.5. So that could be helpful and sometimes. So I just wanted to point that out in case you needed to use it. All right, so I don't think that was super helpful. But I think I'm going to figure out the height. I think that's what I want to do since I have the base. So I want to find this height right here. So since this is 8 radical 3, I know that this right here is half of 8 radical 3. So that means it's 4 radical 3. So I'm going to draw it a little bigger because I'm a little cramped. This is 4 radical 3. I'm looking for the height. And I have that this is 67.5. So I'm going to use the tangent of 67.5 equals the opposite over the adjacent. So my height equals 4 radical 3 times the tangent of 67.5. That is the height of this triangle right here. And I have the base. So base times height divided by 2. And how many triangles are there? 8. So 8 times my base, which is the 8 radical 3, times the height, which is the 4 radical 3 times the tangent of 67.5, all divided by 2. What do we get? Let's see. 8 times 8 radical 3 times 4 radical 3 times tangent of 60. Oh, wrong button. 67. Oh no, you see what I did? I forgot to arrow over. There we go. Tangent of 67.5 all divided by 2. So 927.06 units squared. All right, so try your day 4 homework. Remember, you do have a quiz tomorrow. It's going to be a feedback quiz, and it's only going to be on days 1 through 3. So what we did today will not be on your quiz. If you have questions, feel free to see me the next time we're together, or you can, of course, go to see another math teacher. Have a great day, everyone. Bye.